This is part 1 of the video for 7.6 notes, factoring a polynomial when the lead coefficient is not 1. So if you look at number 1 here, this polynomial is not a 1. The lead coefficient is not a 1. So that's 5x squared. What we've been dealing with up until now has just been x squared, or it's been a perfect square. So I want to try to factor out the GCF. Now I won't always be able to, but in these 6 examples, these are just a review, and I can do that. The GCF here is 5. They all have 5 in common. So when I factor out the 5, this is what my polynomial looks like. X squared minus x minus 1. For number 2, I want this to be a positive 1. So I'm going to factor out a negative 1, and I see that they all have x in common. So that's my GCF. You can pause the video if you want to multiply it back out and see if it works. Number 3, everybody has a 4 in common. Every term is divisible by 4. So I factor out the 4 and get z squared minus 24z minus 2. Number 4, all divisible by 3. So 3 is the GCF. Number 5 looks a little scary because they all have a y, but guess what? That's the GCF. And then finally, number 6, everything is divisible by 15, so I factor out the 15. So we're going to put this together with what we did last week in factoring, and we're going to factor polynomials in the form of ax squared plus bx plus c. What we've done until now, a has been equal to 1, and in this lesson, a does not equal 1. So again, previously we had things like x squared plus 3x plus 2. And we factored the x squared into x and x, factored the 2 into 2 and 1, and then put plus signs, and we were done. So we're going to put that together with what we just did in the warm-up with the GCF. Anytime you can, you want that lead coefficient to be 1. So always check to see if you can factor out the GCF. Every term has a 5 in common, so factor out the 5. Then factor the remaining trinomial into 2 binomials, which is what we've been doing in the previous sections. Number 2, everybody has a 4 in common. Every term is divisible by 4. When I factor it out, 32 divided by 4 is 8. 60 divided by 4 is 15. Now I should have something that is easier to factor. X times x is x squared, and then I ask myself, what are the factors of 15 that would add to give me negative 8? Well, positive 3 plus positive 5 gives me positive 15, but so does negative 3 and negative 5. And now I have factored using the GCF. Now I'm going to stop that video and I'll do the rest of the examples in part 2.